Imagine treating a blockchain like any other backend service you can design, test, and ship. In this course, you'll go from a clean machine to a fully custom Cosmos SDK chain, mastering ABCI++ and building production-grade, application-specific blockchains in Go or Rust. In this module, we're going from an empty shell on your machine to a fully wired Cosmos SDK blockchain that actually talks to CometBFT. Think of it as an ignition sequence. First, we'll lock in your toolchain. Go, SDK tooling, and reliable workflows so builds and tests are painless. Next, we'll scaffold a chain, but we won't treat it as a black box. We'll dissect the generated structure, especially app.go, to see where modules, keepers, and configuration are plugged together. Finally, we'll locate and understand the ABCI and ABCI++ hooks, so you know exactly where custom logic will shape block proposals, validation, and state transitions. Before we write a single line of Cosmos SDK code, we need the right raw materials. You'll need a recent Go toolchain with modules enabled and your Go bin on the path. You should be working in a Unix-like environment with Git, so commands and scripts behave predictably. You'll also need a fabrication tool such as Ignite CLI or the official scaffolding templates. And finally, Docker and Make to give you reproducible, isolated builds and simple automation for everyday tasks. Let's make this concrete. Imagine you're spinning up a brand new chain for an internal payment system. Instead of handwriting boilerplate, you install Ignite and run a single scaffold command. In seconds, you get a fully wired Cosmos SDK app, a modules directory, proto definitions, config files, and a ready-to-run CometBFT node. From a backend engineer's perspective, this is like Go mod init on steroids. You skip the plumbing and jump straight into designing modules, ABCI++ hooks, and business logic. When you open a Cosmos SDK codebase, you're really looking at a few core neighborhoods. The command directory is what node operators touch, binaries and CLI commands. Think of it as the shell around your app. The heart of the chain lives in app. That's where the app type wires modules together, configures stores, and exposes ABCI and ABCI++ hooks. Most of your domain logic sits in one folder per module: state types, keepers, messages, and services. And finally, config holds TOML or JSON that actually runs the network, CometBFT parameters, app settings, and Genesis tweaks. Think of app.go as the reactor core of your chain. It defines the main app struct, which embeds base app, all your keepers, and the module manager. Base app handles low-level concerns, chain ID, logging, and decoding transactions from CometBFT into SDK messages. The module manager is where everything is wired together. It registers message routes, gRPC, and query services, and all the ABCI and ABCI++ handlers that modules expose. When you customize a Cosmos SDK chain, most structural decisions eventually show up here, because app.go is what turns a set of modules into a single coherent blockchain application. In Cosmos SDK, most of your business logic lives in modules. Each module owns a slice of state and exposes messages, queries, and hooks for the rest of the app. Keepers are the internal APIs that actually talk to the KV store. They enforce invariants, control access to state, and hide storage details behind clean methods. Then app.go ties everything together, constructing keepers, injecting dependencies, and making modules feel plug and play. Base app is the bridge between your Cosmos SDK application and CometBFT. Your business logic lives in modules and gets composed in app.go. Base app wraps that and exposes the ABCI methods CometBFT cares about: check to text, deliver to X, commit, and the rest of the lifecycle. From CometBFT's perspective, it's just talking over a socket or gRPC to an ABCI server. Inside the app, you never deal with raw network messages. You implement handlers and keepers, and base app translates them into ABCI responses. So when we customize behavior later, we'll either extend how base app is used in app.go or add module logic that base app calls into. Classic ABCI is basically a pipeline that base app wires up for you. CometBFT drives the sequence: init chain, begin block, deliver to X, end block, commit. Each transaction enters via check to X or deliver to X, then runs through the anti-handler. That's where you do stateless checks, signature verification, fee deduction, and basic auth. If it passes, the transaction's messages hit the MSG server or legacy handlers, which mutate state. Modules hook into the block lifecycle with begin blocker and end blocker. Your customization points are anti-logic, message handlers, and these block-level hooks all registered in app.go. ABCI++ fundamentally changes how your application collaborates with CometBFT. Instead of just receiving a finished block and executing it, the app now helps build and vet that block. Prepare proposal lets the proposer choose which transactions go into the block, and in which order based on mempool state and custom rules. Process proposal lets every validator recheck that proposal against local policy and state before they vote. These hooks are exposed through base app and then delegated into your modules, so business logic can directly influence consensus behavior. Conceptually, you move from a passive state machine to an active participant in block construction and safety. When you're reading Cosmos SDK code, you want to quickly find where ABCI and ABCI++ actually plug in. Start with app.go. That's where modules are wired and where begin blocker, end blocker, and init genesis are registered. It tells you which module owns which phase. Next, look at base app.go. That's the concrete implementation of ABCI methods, including prepare proposal and process proposal. You'll see how requests flow from CometBFT into your modules. Finally, scan your modules for app module and app module basic implementations. Those are the real entry points where your custom logic gets called. Once your chain is scaffolded, the real control surface lives in the config files. Think of app.toml as everything the outside world touches: API, gRPC, course, telemetry endpoints, and how the node exposes your application. This is where you tune observability and operator ergonomics without touching code. Then config.toml and genesis.json describe the chain as a system: P2P and RPC behavior, consensus timeouts, and the initial state of every module, account, and balance. Together, these files are your primary levers for changing network behavior safely without redeploying binaries. Now it's time to actually run your chain and watch ABCI++ in action. First, compile the binary with make install. Then initialize your node with your app's daemon, for example, app.dd init my node. Finally, start the node with app.dd start. As blocks begin to flow, pay close attention to the logs. You should see the block lifecycle: begin block, multiple deliver text calls, end block, and commit. This is your live trace of CometBFT driving the application through the ABCI and ABCI++ pipeline. By this point, you should have a running chain, can build it, and see it talking cleanly to CometBFT. You also know where the classic ABCI lifecycle lives in the code and where the ABCI++ hooks plug in. From here, shift from understanding to shaping the chain. Start by customizing begin blocker and end blocker in one module to add small but visible behaviors, like counters or periodic tasks. Then experiment with prepare proposal and process proposal behind a feature flag, logging decisions. Keep changes minimal, observable, and reversible so you can iterate quickly and safely.